once again, thanks for the warm words, Jessica, and also a warm welcome from my side. I'd like to start with a little poll and would like to ask you, my audience today, who has in the past 6 months provisioned a VM or some other cloud infrastructure in one way or the other? Okay, yeah, quite a few. Who did this in a manual way on a web-based, browser-based UI, something like that? Okay, so that means that most of you probably did some kind of scripting infrastructure as code or something like that. Is that correct? So are there any specific tools that you are using for that? Any ideas? Martin? Terraform? Who else is using Terraform? Okay, so who is not using Terraform but did do some scripting? Okay, and that is exactly why I prepared this presentation for today, because I think as well it feels natural to do provisioning with a tool like Terraform. It's very well known for that, but I was looking for some alternatives, and I'd like to present you today one alternative you probably know pretty well, Ansible, but not for this use case. And that's why I did this presentation. So my name is Nils Magnus. I, as already mentioned, work for Deutsche Telekom, for the Open Telecom Cloud, in the ecosystem squad. In the ecosystem squad, we try to make our customers and users happy because we are providing tooling, libraries, frameworks, and so on that makes working with our public cloud service easier. I'm working since 20 years, take it or give it, in security, operations, and cloud business a little bit. I was working as a tech writer, editor, journalist. I'm still a director and member of the board of the German Unix user group, and so on. I really like to interact with the community, and that's why I'd also like it to interact with you. So if we are especially talking about Ansible, I have to admit that I'm not an Ansible expert, but just a mere user. So if I say something stupid, please raise your hand and let me know so that I can make sure that I don't do this faux pas twice. But, well, let's dive right in it. I prepared an agenda, and actually I stripped it down a little bit already, because about the first half of the agenda we talked luckily a lot already here during stackconf. So why is provisioning important? Why it is important to have a proper infrastructure as code, to have good quality code running and taking care of your infrastructure and so on. So I will keep this very, very short, but on the other hand, I will provide the link to my presentation to the organizers. Thank you, NETWAYS, for having me, by the way. So you can use it also in a way of as a reference manual to replay the short demo that I presented here and prepared. That's why I'm going to step through most of the first half of the slide deck. What is provisioning? What always confused me is that we are talking about configuration management and we are talking about provisioning. And for me, it's basically the same thing, because it's we manage and configure and set up different layers of our software stack, of our setups. And for some reason, we call it configuration if we are talking about applications, and we are talking about provisioning if we are talking about infrastructure. But is that set in stone? I don't know. I was just wondering, and that was actually the initial thought that sparked this presentation here for me. Why should we do infrastructure and managing that, and especially automating that? Well, we talked already about the whole topic several times. I have a quick wrap up here. So for disaster recovery, it's very handy to have a script description where you at a single push of a button can recreate your whole IT infrastructure. That comes in handy if you would otherwise go into a headless chicken mode and try to figure out what went wrong and how to recover from that. So then we talked about configuration drift. So updating and code hygiene is always a good idea. So even if you don't step into a disaster, it can be useful from time to time to rebuild your whole infrastructure, or at least parts of it, or at least in a controlled subset of your components. The third thing is something that we do ourselves as public cloud providers. We do a lot of infrastructure testing. So, for example, we constantly creating virtual machines, tie them together with hard drives and with networks, and build clusters, provision load balancers, and try if everything is working as expected. And that is only possible by a high degree of automation, and that's why we use that as well. And the fourth and not least important idea is knowledge sharing. So if you learn a new colleague, for example, and the new colleague wants to understand your infrastructure, it's a good idea to have a script that explains how you set up your infrastructure, how you connect your virtual machines to each other, what is the design of your network, and so on. Well, let's skip over this. There are several forms of provisioning. You can do it manually. You can write it down in a wiki or on a sheet of paper. I've all seen this. We talked yesterday, and I think it was Chris who mentioned bash scripting. There are even for more complex software things like, say, OpenShift or something like that. There are installers, but what are they doing internally, by the way? Or you could actually do, and I think we all agree on that, should use a domain-specific language or something, some tooling that supports provisioning. And as an exercise or homework, you can try to check how easy is it that a manual error sneaks in one of those principles. How precisely can you define your desired state, or how reproducible is it actually to set up some infrastructure if you use one of the upper layers here and not a defined and verified scripting language for that. Well, infrastructure as code should be declarative. We talked about that. It should be convergent. It should go towards some target. It should be idempotent so that repetition doesn't hurt. And very important, it should also assess and manage in some way, and that is not trivial, status. And everything together is kind of a base requirement for provisioning as well as configuration management. So typical representatives, I put here vSphere because that was a very strenuous experience I made in my life working with that. Most of the people use Terraform today. Pulumi seems to be popular, especially in the high end of infrastructure provisioning and management. Then there are tools like Heat or CloudFormation, or I don't know what the services are called at the other hyperscalers, but usually they also all have something like that as well. But does Ansible also belong to this list? Can we use Ansible for tasks like this as well? And we see this in a minute. As promised, I listed here a lot of keywords. I just want to mention, you know what Ansible is. If you are talking about Ansible, it's important to know where you are. Are you at the controller side or at the target side? We have a short diagram for this in a minute. We are talking about modules, tasks, and roles, and I have also a diagram for that. And we are obviously talking about the cloud. What is the cloud? For me, in this specific environment and context, cloud means some infrastructure resources, servers, networks, storage, and you name it, which is accessible by an API. So what I'm describing here is basically infrastructure as a service, IaaS. So we work a lot with OpenStack. OpenStack is an open source framework, and we have the so-called 4 opens for that. It's open source, open design, open development, and open community. So everybody can participate in this huge ecosystem. And we as Deutsche Telekom, with the Open Telekom Cloud, use and facilitate this open source project and make a product from it. Okay, let's stop the short commercial break here. We have an SDK which sits in front of the mentioned API and abstracts a little bit away from that, because talking directly with REST to the API can be a little bit tricky at times, and the SDK eases this task. Then there is openstack client. That is a command line tool that you can use on your command line, something like openstack server list, and you get a list of all servers. This is not really automation, but sometimes it's useful to have a look at your infrastructure. And we are talking about often if we set up cloud setups about Bastion hosts. Those are systems, virtual machines that sit more or less in front of the actual infrastructure, and you also call them usually jump hosts or something like that. So you connect there via SSH, and then if you really want to and need to, can access some components of the infrastructure by facilitating this Bastion host. Well, Python, a very important and well-known programming language. The OpenStack SDK and most of OpenStack are written in Python. And if we talk about Python, I always mean Python 3 here, at least version 3.8, but should be no big issue with recent Linux distributions. Pip is the package manager, very convenient if you get the hang of it a little bit, and especially in combination with virtual environments, where you can kind of very lightweight, in a lightweight way, create a sandbox and don't ruin your local system and install software like Ansible. Ansible is also shipped by Pip and can be run out of a virtual environment. ECS is an abbreviation for Elastic Cloud Server or just a VM. An image is the installation image, like in Ubuntu 22.04 or CentOS stream, something like that. We have flavors in cloud computing. Flavors are usually also an abstraction of both the number of CPU cores as well as the amount of memory that comes pre-configured in an ECS instance. So for example, something like S3 medium.1 is one of our flavors for a virtual server with 1 core and 1 gigabyte of RAM. Volumes are hard drives. Networks are split up into networks, subnets, routers, security groups, and lots of other stuff. I just mentioned this here because these are all prerequisites we will facilitate to create our Bastion host in a moment. Good. What is Ansible? We make this short as well. So usually we use Ansible to do configuration management, so to create users, groups, install packages, edit configuration files, start services, and so on. And it should be declarative, convergent, idempotent. I already mentioned that. I said it should be because it requires some discipline to actually keep those features. So just by using Ansible or effectively any other declarative configuration management system does not automatically provide these features. Okay, so we see Ansible very well known in the configuration management space, but what changes if we use this as a provisioning tool? So let's have a short look at the architecture. So here are we. We sit in front of the so-called controller node. We check out from a Git repository or else a playbook, and we will execute this by Ansible. It gets connected via SSH to the target system. Something happens, and a report is returned to the user, and you can read that or can store it or put this in your log store or whatever. So that is the classic Ansible operation architecture. And the playbooks are subdivided in tasks, modules, plays, roles, and static or dynamic inventory. You probably all know this, but just for reference, I listed all those terms because when I started with Ansible, I had a lot of issues with sorting up all those terms and what is the difference of a task and a play, what is the difference of a role and a module, and so on. So that's why I listed this here, and this is a very simple example to install an Apache on your system and also provided with a configuration file. Okay, that's something that we know all. And if we do the transition towards infrastructure provisioning, we have to change something because this link, so it's again, we are here in front of our controller system, we check it out from a Git repository, but we cannot just do something with our infrastructure because initially there is no infrastructure. So we have to create it by some way. And we cannot connect to the system which is already there. And that's why we connect via a REST call or several REST API calls to the cloud API, in our case OpenStack. And that in turn manages the infrastructure itself. So managing means not only creation, that is the C and CRUD, but also in retrieving, so to get an overview, how many servers do we have, to update, to change some properties, and to delete those servers, and probably some additional activities and functions there as well. So in this way, we will create servers, we will create networks, we will attach the servers to the networks, we will attach storage to the servers, and so on, creating all this infrastructure. And that's why we need this slightly different architecture for that. And to do this, we usually make a small trick. Inside of Ansible, you can define on which target to connect to perform your actual configuration tasks. And we do this on our own system, on our controller system, on localhost. And then we have to install additionally this SDK that takes those requests from localhost and then translates it to the sequence of REST calls and actually creating the infrastructure. So that is the whole idea of everything. And if you understood this picture, then you are, I guess, 80% through the whole principle of managing infrastructure with Ansible. Yeah, this is more or less what I just explained. Ansible modules are the abstraction layer to accessing the resources, the OpenStack resources, and the SDK is in between. And to tie this directly to Ansible, we have to provide a number of modules, new modules, and those modules are bundled or packaged in a so-called Ansible Collection. And then there is also a tool, Ansible Galaxy, which can query and install those collections. So you do something like Ansible Collection, install openstack.cloud, for example. Together with my team, we develop and maintain two major collections. One is the generic openstack.cloud Ansible collection, which is a joint effort of the community. And we also support the OpenTelecomCloud.cloud collection as well, because that's supporting some extra features that we have in our specific instance of the cloud. But if you want, you can just stick with OpenStack Cloud, and my example, I think, just relies on that. Let's have a look at the installation. It's pretty straightforward. Well, we can probably also skip some of those stacks. We prepare a virtual environment to not mess up our local controller host. We create a virtual environment, NZ demo, enter it, and then update. I always do this, getting rid of those nasty error messages I always get if using pip, to update pip, the installer tool itself. After that, we install Ansible, and I was not sure which way of installation to recommend for some time. But in the meantime, I have decided that it's probably the best idea to have tools like Ansible or the OpenStack tools run out of pip, so the PyPy repository directly, and not to use the operating system tools, which also exist. So for example, I looked up Ubuntu has also Ansible as packages in their pretty new 22.04 release. They have version 2.12.0. I have 2.13.1 out of the PyPy repository, and CentOS is back at 2.9.27. So if you really want to use the latest versions and the latest security updates, it's probably a good idea to actually use this Ansible installation scheme. But you're free what to use. I presented here this way. So 2.13.1, let's see how to continue. Then I installed the OpenStack SDK for the mentioned reasons. And this is a little bit awkward, I have to admit. At the moment, the guys from Red Hat, or the maintainers of Ansible, most of them are employed by Red Hat, are rebuilding a little bit the internal structures of some of the Ansible collections, and that's why it is the easiest way to stick at OpenStack version 0.61.0. That is the latest version that still works with the up-to-date Ansible collections. So we are slowly progressing for OpenStack SDK, which we also support and maintain for the Open Infra Foundation, to version 1.0. That may take a few weeks, maybe a few months, I don't know. And then hopefully this hassle with the version pinning goes away as well. As mentioned, once we have the SDK, we can also install the collection itself, Ansible Galaxy, which comes with installing Ansible itself. You just install it, or if you want to extend even both the SDK as well as the cloud collections, you can use the two lines that I put here on the lower box: pip install OpenStack SDK 0.61.0 and OTC extensions, as well as the two collections. Good. If we are talking about the cloud, we have also talked about how to communicate with the cloud. I said there is an API, and using this API requires some authentication. And there are several options in several bunches of documentation describing how to do that, including environment variables or command line switches. But I do not recommend them because they all come with security issues. So, for example, if you type something with OpenStack --os -password equals my super secret password, it ends up in your shell history, for example. It can be looked up there. It can be easily sneaked by looking at the process list. Same applies under some circumstances for environment variables. So the best way is to create a file like this cloud's YAML in the mentioned paths. There are several options, and put in some profile, as I prepared some here. If you want to replay the whole demo on your own, I created a small repository, AC demo, Ansible Collection demo, and you can check it out, and together with the actual Ansible script that I'm showing in a minute, you can edit this if you are using some OpenStack-based cloud. So, for example, with the NETWAYS cloud. So you're running some OpenStack service as well, right? All right. Good. As you can see, I start out my password there. That is actually a bad way to do so. The best way would be to delete it completely out of this file and put it in a file with the same structure, but just with the password entity in secure YAML, so you can split those secrets a little bit. or use one of the password vaults that you are most familiar with. So there are countless options. As I said, sometimes it's useful to have also the CLI available. You can install it, this pip install update if you want, openstack.cloud. That is also the name of it. And there's a lot of help. You can do then something like OpenStack list server, OpenStack show server and the name and so on and so on. Good. And now, as time is going to run out, my actual script, I set up an all-in-one script, and the important part for provisioning are the first 2 pages for this. I created one single file, all-in-one. It's also in the Git repository, and it basically defines a lot of variables at the beginning. So to make this example not too complex, I created some of the resources manually before. So for example, the router or the network or the subnet. But if you understand this example, you can easily extend this script to create all of them as well. So is there something noteworthy? I think most of the variables are self-explanatory. I create a lot of names. I define where the server is located, in which region, and in which availability zone. I have to define a security group, that is a firewall rule that is very common for cloud setups. I have to select what kind of operating system to install. In this case, I looked up the available ones and choose the Ubuntu one. You should upload SSH public key so that you can actually log into the server. And you have to provide the flavor, which I just mentioned. So with those variables, you just have to instantiate those variables. That's mainly the same thing again. But let's have a look at task number 1. So upload an SSH public key, which just creates a new resource, and that's basically it. You just provide the information, uploaded it, and it's there. It gets translated to the API calls. It gets translated and created on the server side of your cloud. And the same thing, so task number 2 is probably the core idea of everything. It creates the Bastion server, and something noteworthy is the last line, register return server, because each module returns some data. And the return server is a JSON structure, or think of it as a JSON structure that can retrieve important information for next steps. So next steps could be to display the IP address of the new server, just as an example, or to take this server and update your local host file, SSH host files. Otherwise, you get one of those nasty warnings. You just have to manually, which we want to avoid, remove. And well, the next steps, let's not dive too deeply into it because we are running out of time. This is just normal Ansible activities, updating packages, installing new ones, deleting some files I want to get rid of, and doing some housekeeping. We could do some user management, creating groups, adding those groups to certain users, setting a local password if you really want this or need this, and so on. So to run everything, it's just a single line, Ansible playbook, all in one, and then after about 2 or 3 minutes, everything is set up and you can recreate everything pretty easily. I skipped the dynamic inventory. That is could be some nice extra extension, because the cloud knows about your infrastructure and your assets, and you can ask it directly, so you don't have to keep it in a file. And one last remark: if you want to support us or to support the community at large by extending, by testing, by doing documentation, those are the links to find the sources. Everything I presented here is released under open source licenses, either in our repositories at openstack.cloud or directly at OpenStack. Here is a link to a architecture file from the maintainers of the collections. And with that said, I would like to thank you.